Carbon is everywhere. Carbon and life basically go hand in hand. What separates the organic from the inorganic is the way that carbon molecules are arranged. It's the backbone for the four organic compounds: lipids, proteins, nucleic acids, and carbohydrates. Valence electrons are those on the outermost shell of an atom. Covalent bonds happen when atoms share those electrons. It goes a little something like this. Yo, Colin, what's up? Hello, Carbon. My life sucks. I have 4 electrons in my outer shell, or valence electrons, and I want 8. I want 8. And if I don't get 8, I will become radioactive, and I will become an unstable atom, and then everything will just be so wrong. Dude, that's totally my problem as well. You know, we should share electrons and covalently bond, and have a few buddies out there who'd be happy to bond with us as well. You know, that's not actually a bad idea. So what do you say? Okay, so maybe it goes nothing like that, but the general principle is the same. Carbon has a bunch of different allotropes. What are allotropes, you ask? Well, they're different forms of an element and have different molecular structure. A really good example of an allotrope of carbon is graphite.
Graphite was discovered in England in the mid-1500s. A village discovered solid graphite deposits and used sticks of the substance to mark sheep. The molecular structure of graphite is basically one atom thick sheets of carbon bonded together in a hexagonal pattern. However, there are weak bonds between different sheets. Graphite is a brilliant lubricant and a good conductor of electricity. It resists temperatures up to 3,500 degrees Celsius. Because of this, graphite is not only used in pencils, but also used for making electrolysis cells and electric motors and generators. According to ancient Hindu scriptures, diamonds were discovered in prehistoric times. They are one of the hardest materials on Earth, which make them very useful for drill bits. But they are brittle and can be broken, though only with another diamond. It's a brilliant thermal conductor, but a bad electrical conductor. Diamonds are hydrophobic and don't react with acids. Diamonds can resist temperatures up to 3,500 degrees Celsius. They burn or oxidize in the presence of oxygen and melt to form amorphous carbon. A diamond molecule is basically a conglomeration of covalently bonded carbon atoms. Buckminster fullerene is a different kind of carbon molecule. It has 60 atoms and looks like a hollow truncated isohedron, which translates to a soccer ball. It has interlocking pentagons and hexagons. Little is known about Buckminster fullerene, but it can be a conductor, insulator, semiconductor, or superconductor of electricity.
A really good example of an allotrope of carbon is graphite.